In this video, we're going to look at the binomial theorem and how to use that binomial theorem to write out binomial expansions or define just one specific term without having to expand. This should be a review from Algebra 2. Make sure you have your paper set up in Cornell Note format. So when we're talking about binomial expansions, we're talking about taking a binomial, which is two terms. The x plus y is a binomial because the x is a term and the y is a term, and then raising it to a power. So if I have to do x plus y to the fifth power, remember what that really means is x plus y times itself 5 times. Okay, so what we would have to do would be to take the first two x plus y's and multiply these together, get an answer, and then take that answer and multiply it times the next one, and then keep going until we have multiplied times all five sets. Okay, now that is a long process to multiply it by hand, and there are lots of places to make tiny mistakes that will mess up the rest of the problem. So it's helpful to have a shortcut in writing out what the answer to this would be without having to do all of the multiplications. And that is where the binomial theorem comes in. Okay, so to use the binomial theorem, we need to talk about Pascal's triangle. Pascal's triangle is a pattern for the coefficients when you take this binomial and you expand it. Okay, so for example, if I say x plus y to the 0 power, anything to the 0 power is just 1. So the top of our triangle, we start with the number 1. Okay, if I take x plus y to the first power, it's the same thing as x plus y. Well, the coefficient of x is 1, and the coefficient of y is 1. Okay, now if I keep going, x plus y squared, that's a pretty quick expansion we can multiply in our head, and we would get 1x squared plus 2xy plus 1y squared. Well, our coefficients are 1, 2, and 1. Notice the outside of this triangle is always 1, and to get this 2, if you take the row above it and add those two terms, you get the 2 that's in the middle. Okay, so for x plus y cubed, okay, we're going to have a 1 for our first coefficient. If I add these two numbers together, my next coefficient would be a 3. If I add these together, again I get 3, and then I'm going to end on a 1. And I can keep expanding this. So the coefficients for x plus y to the fourth, okay, a 1, then 1 plus 3 would be 4, 3 plus 3 would be 6, 4, and 1. And again, notice the outside of the triangle is always a 1. Okay, I'm going to go one row further. Okay, so if we say x plus y to the fifth, okay, I start with 1. To get the next number, I take the previous row and add. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 again is 10. 4 plus 1 is 5. And then we end on a 1. And you'll notice that each one of these rows is very symmetric. Okay, so again, those are just coefficients. Okay, so how do I get the variables back in there? Okay, so for the variables, we know that x plus y, well, this first one would just be 1x plus 1y. And we know that xy squared is x squared plus 2xy plus y squared. So let's kind of look at what's happening with our variables. So I started with x squared, and then I had an x to the first, and then I didn't have an x. So on the next row, if it's cubed, I'm going to start with an x cubed, and then I'm going to have an x squared, an x, and then no x at all. Okay, now the y's start from the back and go this direction. So I had y squared, y, okay, y squared, y, no y. So here I would have a y cubed, y squared, y to the first, and no y in this first term. Okay, and then all I have to do to finish this out is put plus signs between. Okay, so again, x to the fourth, x cubed, x squared, x, and no x on the end term. but I'm going to start from the back with my y's. So y to the fourth, y cubed, y squared, y, and no y in the first term. And since these all had pluses, I'm just putting plus signs. We'll talk about what to do with a negative in a minute. Okay, so take a second, see if you can fill in that last row. Okay. So again, we're starting with the fifth power. Pause if you need more time. Okay, so I'm going to say x to the fifth, x to the fourth, x cubed, x squared, x, and then no x in the last part. And then the y's go from the back to the front. So y to the fifth, y to the fourth, y to the third, y squared, y, and no y in the first term. Okay, so that's a quick way to expand. Now, look at how quickly we got this answer, and it was a whole lot easier than having to multiply out x plus y times itself 5 times. Okay. Now, if it's just x and y, it's a pretty simple expansion. But what happens if we have coefficients in there? Okay, so we're still going to use Pascal's triangle to get those, to use the exponent to figure out what our coefficients of the terms should be. But now, instead of just saying x squared and so on, we're going to use the 2x for the first term and the negative 3y for the second. So again, if it's to the fourth power, look at your fourth x to the fourth, x plus y to the fourth row of Pascal's triangle, and we had a 1, then a 4, then a 6, then a 4, and then a 1. Okay. Now remember, before we just took the x's and we went x to the fourth, x to the third, x squared, x, no x at the back. We're going to do the same thing here, but it's not just an x, it's a 2x. So I'm going to have 2x to the fourth, 2x to the third, 2x squared, 2x to the first, and then no 2x at the very last term. And notice I put those in parentheses because that exponent also applies to the 2 that's with the x. Okay, now let's start from the back and do the y's, but it's not just a y, it's a negative 3y. So I'm going to have negative 3y to the fourth, negative 3y to the third, negative 3y to the second, negative 3y to the first, and then no y term in the first part. Okay, now the signs will take care of itself as we multiply these out, and then we'll talk about a little pattern that you've got here. Okay, so now we need to multiply these out and get the terms to be one single term instead of things multiplied. So 1 times 2x to the fourth. 2x to the fourth, remember you've got to do 2 to the fourth and x to the fourth, is going to give us 16x to the fourth. Okay, over here I'm going to multiply or take care of the exponents first, and then we'll multiply to get the final term. So 2x to the third would be 8x cubed times negative 3y and times 4. So negative times positive is going to give us a negative 96x cubed y. Okay, now let's take the next one. 2x squared would be 4x squared, so 6 times 4x squared. And then negative 3y quantity squared, negative times negative is positive 9y squared. And when I multiply 6 times 4 times 9 and x squared, y squared, I'm going to get plus 216 x squared, y squared. Okay, now let's do the same thing on the next set. So 4 times 2x, and then negative 3y quantity cubed would be negative 27y to the third. When I multiply that, 8x times negative 27y cubed, you get negative 216xy cubed. Okay, and then for our last term, all we have is negative 3y to the fourth times 1. So that's going to come out to be positive 81y to the fourth. Now look how quickly we were able to come up with the product without having to multiply 2x minus 3y times itself 4 times. Okay, look at the signs for just a second. So the first one came out positive, and then it was a negative, positive, negative, positive. When you have a minus in your binomial, if it's subtraction instead of addition, every other term will be negative. So it starts on a positive, and then it would be positive, negative, positive, negative, positive, negative, and it would continue in that pattern. If it's a plus sign in your binomial, then everything's going to come out positive. Okay. Pause the video for a second and see how far you can get on this expansion, and then start it when you're ready to check. Okay, this time we have an exponent of 3. So if you'll look at the row on Pascal's triangle that was x plus y cubed, the coefficients that we had were 1, 3, 3, and 1. And I hope you've also noticed that the number of terms in your answer is 1 more than the exponent. So if it's an x cubed, I'm going to end up with 4 terms. Okay, now when we're doing our expansion, remember our terms aren't just x and y. Okay, but again, we're going to take that 2x squared and we're going to put it in parentheses. So the first time it's to the third power, then to the second power, to the first power, and then no 2x. And I forgot the squared, so let's go back and put those on there. Okay, the 3y cubed, we're going to start from the back and go to the front. So 3y cubed to the third, 3y cubed to the second, 3y cubed to the first, and then no 3y cubed in the first term. Okay, so here are my 4 terms. I'm just going to draw a line between them so that we can keep them separate. So now we just have to multiply them out, and we know that they're going to have plus signs because our binomial had a plus, so everything is positive. Okay, so let's multiply this out. So 2x squared cubed. So we're going to end up with 8x to the 6th, because you're going to multiply your exponents when it's power to a power. Okay, over here I've got 3 and then times 4x to the 4th and times 3y to the 3rd. So if I multiply 3 times 3 times 4, I'm going to get positive 36 x to the 4th y cubed. Okay. In the next term, we've got 3 times 2x squared times 9y to the 6th. Again, the y to the 6th is because you're going to multiply when it's power to a power. So when I multiply those all together, we come out with 54x squared y to the 6th. And then our last term, 3 to the 3rd is 27. And then y cubed to the 3rd would be y to the 9th. Okay. Don't try to do all of this work in your head. Notice how I wrote down on this step how I was setting up each term, and then don't try to do too many things at once. Notice again that I did the exponents and then I multiplied. I didn't try to do it all in my head. So you will make less mistakes if you will show your work. I do want you to write down all of the step of setting it up on your paper. Okay, now quickly let's talk about how do you find just one specific term without having to expand the whole binomial. So if I just want the 5th term, or if I just want the 2nd term, without having to multiply the whole thing out, how do I get one term? And this is the formula, so if you will underline, highlight, put a box around. Okay, let's talk about what these variables mean. Now, x and y just refer to the first term of your binomial, and y is the 2nd term of your binomial. So it won't always be x and y, just like in the parentheses when we had to put the 2x or the 3y cubed. Okay, n is your original exponent on your binomial, because we're working with binomials in the form x plus y to the n. So n is the original exponent. and r is 1 less than the number of the term you're trying to find. So if I'm trying to find the 5th term, then my r is 4. If I'm finding the 8th term, my r is 7. Okay. So let's find the 3rd term of 2x minus 3y to the 4th power. Okay, so in this case, our n is 4, and our r, if I'm trying to find the 3rd term, remember r is 1 less than that, so r is 2. Okay, and I'm going to write our formula down again before we start to work this out. Okay, so n factorial would be 4 factorial. R factorial is 2 factorial. And then n minus r, 4 minus 2, would give us another 2 factorial. Okay, x is not really x. X is the first term. So the first term for us was 2x to the n minus r power, which would be 4 minus 2. And then our y, again, is not really y. It's the second term. So it's going to be negative 3y. And then that's to the r, so to the second. And notice I did include the negative with that second term. To get your signs right, you're going to need to include the negative. Okay, so let's work this out. Remember your factorial rules. 4 factorial is really 4 times 3 times 2 times 1. 2 factorial is 2 times 1. So let's do a little canceling. Okay, so the 1s aren't really going to change anything when you're multiplying and dividing, but I can cancel this 2 with this one, and this 2 with the 4. So all I really have left is 2 times 3, which is 6. Okay, so now I've got 2x quantity to the second power. So when I square that, I get 4x squared. And then negative 3y raised to the second power would be 9y squared. So I'm going to multiply those numbers out. 6 times 4 times 9 is 216. And then I've got x squared, y squared. Okay. Now, we actually expanded this binomial just a minute ago. So let's look back at the answer we got for that, and let's see if our 3rd term matches what we just got here. Okay, 3rd term, 216 x squared, y squared. Same thing we just got using our formula for one specific term. Okay, here's another example. Pause the video and see if you can find the 5th term of x minus 5 to the 8th. Start it back up when you have an answer or you've gone as far as you can go. So in this problem, our n is going to be 8. That's our original exponent. And r, if I'm looking for the 5th term, is 5 minus 1, or 4. So again, remember your formula. Okay, so n factorial would be 8 factorial over r factorial is 4 factorial, and then n minus r, 8 minus 4, is another 4 factorial. Okay, x is actually x in this case. It's our first term. So we would have x to the n minus r, which is 8 minus 4, or to the 4th. And then we're going to have y to the r, which is y to the 4th. Okay, and actually I should have put that as negative y to the 4th, which isn't going to change anything, but because of this minus sign here, I need this to be my second term. Okay, so let's do the factorial expansions. And this time I'm not going to write the 8 all the way down. 8 factorial is 8 times 7 times 6 times 5 times 4, and I'm going to stop there because I can get the 4 factorial to cancel with one of the ones on the bottom. And then 4 factorial would be 4 times 3 times 2 times 1. So 4 times 2 is 8, and 3 will cancel with the 6 to make a 2. So I've got 7 times 2 times 5, or 70 x to the fourth, and then negative y raised to the fourth power. Negative to the fourth power comes out positive y to the fourth. And actually, that should not have been a y, it should have been a 5. So let's change this part. Let's fix that. So this should have been negative 5 to the fourth power. Negative 5 to the fourth would be 625. And it's still positive because negative times negative times negative times negative. And when you multiply this out, you're going to get 43,750 x to the fourth. Okay, so remember that your first term, second term, whatever you use for the x and y, is going to be whatever's the first term and the second term in the parentheses. If you have questions, put a mark beside anything you need to ask about in class.